Hi there, my name is Anastasia, and I'm glad to meet you on this VOD format of Warsaw IT Days. If you clicked on this link, it means that you are interested in the topic of cyber deception. And today I want to show you some examples, some insights from my job, because on daily basis I work with this technology. So we will discuss some cases that me and my team have encountered during our experience with this technology. So without further ado, let's proceed. Before we do so, we need to define cyber deception, what it is. If we Google deception or check in vocabularies, in Oxford Dictionary, for example, you will see that deception, it is the act of deliberately making someone believe something that is not true. So in some ways, it's about lying. Of course, in day-to-day life, in our normal scenarios, when interacting with people, it is considered immoral. However, in cybersecurity, deception becomes a tactic that allows to detect the activity using decoys. So we deceive the adversary to make them play with the decoy, and as a result, we receive a notification. After that, we can either stop what they are doing, or we can leave them continue playing to get more intel about their techniques, tactics, and sometimes even tooling that they are using for performing their operations. So, about decoys, in general, everything can be a decoy. It can be, for example, a network host, a host of the network. It can be file decoy. It can be account. It can be anything. So even a sandwich that you leave on the counter to check if your colleagues will take it, it can also be considered a decoy. So when we talk about uh, detection using deception, we can even talk about network monitoring based on this technology, or even intrusion detection system. Because in ideal scenario, nobody should be touching your decoys; they should remain silent. And if somebody does it, it doesn't necessarily mean that it's an adversary. It can be also a network misconfiguration, which also should be patched. But in general, that's one of the advantages of cyber deception is its minimum quantity of false positives. The less false positives you get, less your team has to do a job, so less work for your team to do, and you can focus on what actually matters, what actually should be done. Okay, so before we also proceed with the cases, I want to add some notes. First, I won't be naming the companies where we encountered such situations, though I will be defining their sector. You know, OSINT is still a thing, and we don't want them to be exposed. I also won't be showing their confidential info, but I have reproduced some of the events in my lab, for these illustrative purposes, so that you will see how it looked. Those slides will be marked accordingly. Okay, so let's begin. Our first case is best strategy for placing decoy. Quite often, I would say at least a couple times a week, I got asked, so, hi, how should I know which decoys I would like to, which decoys I have to deploy? How do I choose the types? Because there are plenty. Some are basic IT like DNS, FTP, etc. Some are OT, some IoT, some from health sector, and etc. So when actually talking about decoys placement, you can always, Google and find plenty of marketing materials that will suggest an answer. Copy your existing infrastructure. It sounds logical, so this way you can blend the decoys completely in the infrastructure. However, this case that we will see today will show an opposite approach. Let's see what we have. So it was a government institution Once they contacted our team with a question which types of deco they have to use, we suggested adding some unusual devices such as OT and IoT. So the idea here stems from the simple fact, you know, we're all humans, and so do the adversaries when we talk about real people, when we want to catch real people, not some crawlers or something like that. And for us as people, it is impossible to learn everything that is available in this world. Every protocol, every technology, it's just impossible. There are tons of them. So adversaries tend to have specializations. Some are keen on web, some target Windows infrastructure, Active Directory and stuff. Some work with OT devices because usually they lack some security mechanism. Usually, or I would say quite often, they lack some security mechanisms. So there is a room to actually play around. So if this person, if this adversary finds something that is more familiar to them, more likely that they will continue with this resource. Just think about it. If you have a network full of different devices, of course you will be targeting what's easier. It's the concept of this low-hanging fruit in the penetration testing. And one day, this client received a series of alerts indicating some some bad activity within the network. After some investigation, we were able to define the sequence of action. In short, the steps can be summarized in three main actions. First, it was network scan. So scan the entire subnet. It's not something critical or criminal. After all, certain tools in your network can perform periodic scans. Periodic, for example, mass pinging, especially it's a thing for those, smart devices, smart everything that we have in our homes. So as a result, several new hosts were found. Next, our adversary proceeded to investigating some unusual hosts. After realizing that one of the hosts found was namely a PLC emulations from Siemens, he moved on to the next step. It was attempting to exploit. So at this point, when you see that a person sends targeted exploits in your network, you already know that it's not, something that a person just accidentally saw in the network and wanted to know what is this the new host. So yeah, the exploitation attempts included available exploits to attack the found host. It was something that you can find on the internet. And this is how we were able to catch a malicious insider. So malicious insider is somebody who is a legitimate user but performs some malicious actions within the network. So this person was present in the infrastructure for a long time, and now it was exposed. So let's see how it looked for SOC team, Security Operations Center team. The video was reconstructed, and on here we can see step-by-step actions we saw on the previous slide. So what happened? We gathered everything that we had from decoys, we correlated it, and as a result, we have alerts which explain step-by-step actions. So here you can see that the alerts here are displayed in a stacked manner. So, in terms of adding new records, so new alerts appear on top. So this is how you read the slide. So records in the picture should be viewed from bottom to top. Each alert also has an additional information that was used for our research. First is details, like additional information to what we see on this upper slide. It's network dump, so we had pickups that we can continue work with, mapping to Mitre to know what exactly happened, because algorithm can sometimes be blurry for different people, but with Mitre, you know exactly what is going on. and events. So those are raw data from decoys. So to summarize this case, the more choice you provide, the more information you will actually get. Let's proceed with our next case, which is do not forget about web deception. So, it's almost impossible to imagine modern life without web. You even watch this video from your browser, at least I believe so. I'm not sure about the format. And today we will see how we can work around it with deception. So what do we have? This time it was a financial institution. It processes a large, vast volumes of confidential data. And among other things that they ask us to help with, it was dealing with the risk of the man-in-the-middle attacks and lateral movement. So what did we use to address this specific request? It was decoy that emulate web, and there was decoy that emulate user activity to make this whole installation more alive, like to blend it more precisely. So the first thing that we have is web deception. So from here you can see it is a special technology that allows us to create complex web emulations that emulate, real resources that you have in your environment. So in this solution, it's called Universal Web Point. And what it also does, except for emulating those web services, it also adds a number of vulnerabilities to make them more interesting, to make them engaging. Remember our previous case when we stated that the more toys you play, the more toys you give, the more ways to interact you give, the more information you will get by the end of this activity. In addition to that, this decoy has built-in web application firewall, which is based on WebCRS for more clear detection. And for example, I have created an emulation of my website, so you can ask my colleagues. I really enjoy playing around with our website. But anyway, you can see the example, and the client did the same. So using the configuration, it was in YAML format and specifying the appropriate upstream URL, which means the address of what will be evaluated. We were able to create this complex decoy to interact with. So you can click between tabs and see how it works. So these decoys work as if they were real web services, but this way, the attacker who tried to attack and imported web services for the company fell into a trap instead of causing damage to the real system. Next, let's talk more about emulating user activity. For this, we also used an additional type of decoy. In this scenario, it was client-OS. It's called client-OS. So those decoys, they create realistic behavior of end devices. And to fulfill this goal, it can perform regular requests for resolving host names and domain names via DNS, net bias, and etc. It's HTTP requests to resources that you specify. It's a request for a list of file resources. It can also optionally respond to incoming requests, as you can see. Regarding man-in-the-middle techniques that we mentioned, that was important for the client in this situation. This decoy covers RP spoofing, it covers different types of resolve poisoning, and HTTPS request interception. Advantage the stuff, I noticed that we still have some time left, so let's actually try and see how some of the decoys that we mentioned, they actually look. Because to my liking, from my perspective, it's always better to see something rather than to hear about it. So on the screen, you can see now an emulation of Ubuntu.com. So one of them is real, and the second one is an emulation. We can see maybe you want to get a Ubuntu Pro. Okay, fake. This one's real. Let's scroll down and here how it looks. But we can go further and try to perform some, simple attacks. Let's have it, for example, an LFI. LFI is a quick tool to check for some basic vulnerabilities. So I will assume that this host is running on Linux, and we'll try and get, for example, list of users. Okay. And I will copy the same values in here, just, to make sure we are fair. Let's see what happens with the real website. Nothing. And what happens with the ID query? We get a result. So this stuff is fully made up by the system, but this is about engagement. So we can continue further. We can, for example, get ATC shadow and play around with cryptography. We can also add some fake paths and add some residual files, some configs, some forbidden admin pages, and etc. So it's all possible in here. And let's continue with our presentation. So the effectiveness of this solution was proven by the client's internal testing. Let's go to our next case, which is detect human errors before somebody else does. I also like to call this case, if you wish, that your main cybersecurity problem is usually between your monitor and your chair. But we will see. In fact, this example is one of my favorites because it also shows how deception helps to detect network misconfiguration before someone exploits it. This is what I mentioned during the introduction. So let's proceed. We have a partner. During the POC, to continue with documents and some legal stuff, they received a series of strange alerts. Why so? Because decoys without having access to the public networks, to the internet, and don't have any public IP addresses themselves, they received requests from public IPs that we received alerts from public IP addresses. So in this case, you can see it was an illustrative reconstruction of the events. It was also performed there, and no client data is shown on these images. So at first glance, they could even be attributed to false positives. But as we know in cybersecurity, such bells, such tiny details can predict and even stop something on set of more serious consequences. So our partner shares the same opinion, and that's why these anomalies caused concern. And the partner contacted our support team for us to help identify what was the reason. So we began a detailed investigation of the data, including the alerts and the previously mentioned network tabs. So let's see what was an issue here. The interesting detail is if we get to know those public IP addresses better, public IPs that caused the alerts to happen in the first place, they belong to some known services like Facebook, like some like Medium, like AWS, and etc. So in our case, it was one of the Facebook addresses. So again, as you can guess from the illustrations, the reason was a conflict of IP addresses in the same network. So in this example, the real host of one of the employees had the same address as the decoy. And as a result, one of the hosts was sending requests to external resources, but due to the IP address conflict, the other host was receiving responses, which caused the abnormal alerts that we see. So after this conflict was resolved, we didn't see any new similar alerts to appear. Let's also talk about passive and not only passive detection. So everything that we saw earlier, it was about this passive part because deception in its nature is passive. Because before, for us to get an alert or for us to get notified, somebody should interact with the decoy. If we talk more about this network monitoring approach using deception or intrusion detection using deception, we also should think about this active part. What can we do in order to identify those weaknesses in the network before somebody else does? And for this, we can use attack vector validation. So this is an additional module that allows us to constantly check infrastructure for those weaknesses. Let's cover some basic examples. So the first one is security controls validation. Let's imagine you have your structure, you have already some tooling, you bought it, and you want to check if it works correctly, if you have configured it properly. For this, you can create scenario that will regularly check and will also provide you with a report as a result. Next is security policies validation. What does it mean? Let's imagine a situation. You have a firewall perfectly configured, everything is okay, but you need to add something. So we all humans and your admin can put any just for testing, go for lunch, and then return and forget to remove this rule. This can happen, with human mistakes, human errors here. But it can cost a lot of money for the company, a lot of troubles in the future, and we want to avoid the situation. We can also use attack vector validation here. Next, we have SOC team efficiency validation. Also, let's imagine situation. You have a contract with external SOC, so you outsource your security operations center. In your contract, you see that they have specified a certain SLA, but you need to know if this SLA is actually working. It's really bad idea to test the parachute when you already jumping. So it's always better to check in advance, and you can also do it with attack vector validation. So you can see how the team operates enough if the response is as you expect, if it's correct, if they are following the protocols that were specified. So this is also one of the cases that we can talk. From my perspective, to the use cases that we saw, I would personally add this compliance check. Of course, we don't have a tick like check me for compliance if I'm compliant for example, PCI DSS that you can see on the screen, but you can partially check it using this module. On the screen, you can see PCI DSS Quick Reference Guide. It helps you, quickly understand what should be done. For more precise details, of course, you should check the full documentation. So what do we see? It is a common example. It is a common sense. Do not use vendor supply defaults for system passwords and other security parameters. So our task here will be to check for the usage of default credentials, of default usernames and passwords on the, for example, SSH hosts. So what do we have? The main idea of the configuration will be first, we need to understand what we should do. We have it. We want to check for credentials. How we can do it? First, we need to define what exactly will be those default usernames and passwords, because every system has a different, for example, Kali, root tour, or anything like that. You form a payload from them. So you form default usernames and default passwords for this. Then you should create a scenario, which means what exactly will be done step by step, your actions, what you will be performing. And after that, we can cover it up by creating a simulation. So simulation will include additional parameters like who will be performing the action, what is our starting point, because scenario works in this way that results from one step goes to another. So this way you have this chain of reaction. If one step of this action of this scenario fails, then you won't be able to proceed further. And yeah, we put it into simulation, and when we have simulation, we can also specify how often it will be working. Like it can be daily, monthly, it can be only on weekdays. For example, you can configure your reports to be sent, for example, on Monday morning to check and to send for management, for example. So let's see. This is the example of what I have configured for today, for the scenario, for the example that we decided to have. I first start with a ping because I want to know if the host that I'm checking is actually available. After that, I would like to continue with a port scan. Because we deal with SSH, 22nd port is exactly what we will be targeting. Next, I will perform a brute force using the payload that we have specified earlier. And if it's successful, if those credentials are valid, then I want to go further and execute commands via SSH to see what can happen if the attacker actually finds those credentials. But this step is completely optional. On the picture on the right, you can see what I have configured for a simulation. We see that I need an agent to perform it. In the situation that I was actually working with, those agents were already part of a platform, so no need for me to install anything else, so we can work around that. Next, it's scheduling. So I decided that I want to check every weekday at 12 to see how is it going. And then I choose a scenario that is specified on the left picture. And as a result, every weekday I check my host and also I get a report. Of course, it can be, a little bit of overkill to check it every weekday, but you can make it less often. The only thing for you is to be cautious and to remember that you need to check your infrastructure. You need to know what is going on in it. You need to know exactly how it is configured, if it's configured correctly. So, for example, you can check your config, but it won't tell you a thing. Config BE can be like tons of files combined in one, and sometimes it's hard to predict what can be. So, or sometimes you need this tons of experience. So it's always better to have someone or something that will cover you up, that will do an external check here. Okay, so that's all from my side. Thank you for watching. And remember to leave your questions and raise the presentation in the section below. It was a pleasure to once again meet you today. Feel free to contact me on LinkedIn, and I will be looking forward to see you, and have a nice day. Bye.